How would you know that?
All right, so we are going to talk about how we can use parallel lines in our transversals. So, what happens when our lines are parallels that are cut by the transversal?
They are equal.
So, please write the following in the corresponding angles box. If parallel lines. Now, technically, it should be if two parallel lines are cut by a transversal as your hypothesis. But we're going to go lazy and just say if parallel lines. Then our conclusion is corresponding angles are congruent. If it were me doing my proof, I would personally just do if parallel, then corresponding abbreviated angles congruent. That's the really lazy version. Feel free to do the really lazy version. Okay? You can use the symbol for parallel lines instead of writing out parallel lines. You can abbreviate corresponding to just core. You can use the symbol for angles, and you can use the symbol for congruent. So notice in the diagram, I marked angle 1 and angle 5 as the example of the corresponding angles. So because these are corresponding angles, and we know we have parallel lines, then I know that they're going to be congruent. So angle 1 is congruent to angle 5. Now we got to take a pause for a quick second, because there's a new notation being introduced in this section, which is these little arrows that are kind of tiny on the lines there. I want you to kind of put emphasis to them. So I don't know if you want to retrace them and make them a little bit bigger so you can see them. Whenever you see arrows on lines, that's telling us that the lines are parallel. Just like we use a tick mark on a line to show congruency, we use arrows to show that lines are parallel. So you can only assume that you have parallel lines when it has those arrows on it, like that. Okay? So in this section, you are going to be given parallel lines. So your hypothesis of your if-then statement will always be talking about if you have parallel lines, then what? Okay? So corresponding angles will be congruent. Alternate interior. So if parallel lines. Then alternate. And if you just want to write interior angles are congruent. Feel free to abbreviate that however you want. So again, we're given parallel lines. I know I made those kind of tiny on my diagram there. So they have the little triangles. So we know that they're parallel lines. So 4 and 5 are my alternate interior angles. So then I would know that angle 4 and angle 5 are congruent. What's true about alternate exterior angles? What do we say? They're also going to be congruent. Good. So if parallel lines, then alternate exterior angles, alternate exterior angles are congruent. So again, we're given the triangles on our lines. That's telling me that my lines are parallel. Angle 1 and angle 8 are my examples of the alternate exterior. So if we have the parallel lines, then we can conclude that the two angles are congruent. So angle 1 is congruent to angle 8.
I don't like that little swirl.
Yeah, just do your best to swirl it. And then what was true about consecutive interior?
They are opposites.
They weren't congruent. What were they?
Opposite congruent. Discongruent.
What were they?
I forget.
This is going to let me go back.
Supplementary.
Oops. They were supplementary, right?
Oh! Hear that one, Martin? I think that.
So if parallel lines then consecutive interior angles are supplementary. Or if you just want to write sup, you like to just write sup. So angle 4 and angle 6 are my example of supplementary angles there. So if I know I have parallel lines, so the triangles are on there, then the measure of angle 4 plus the measure of angle 6 equals 180 degrees.
Oh boy, not this hard.
All right, so the first two examples, we do not have to provide any justification. We just have to find the actual degrees of the missing measures. But the backside we do. Questions? You guys have different numbers? You have 3 and 5? Oh, that's weird.
It's on the opposite side.
So yours would be 3 and 5?
Yeah.
All right, thanks. I'll change that. No one else told me about that. All right, here we go for the first example. Find the measure of angle 1. What would be the measure of angle 1?
Number 1.
Why is it 50 degrees?
Because it's the opposite of the other.
What do we call that? Vertical. Good, Larson. Vertical angles are congruent. What will be the measure of angle 2?
It'd be 100 and something. 130.
Why do we know it's 130?
Because it's the opposite. It adds up to 180 equals 180.
So if lines are parallel, then consecutive interior angles are supplementary.
130.
Right? Would be the proper justification. Okay. Next example. We're finding both x and y. I know it just says y in our problem. So here we have x we need to find, and we need to find y. So let's focus on the parallel lines. I'm going to highlight the parallel lines in red, and I'm going to make a transversal here. I'll do this in a different color. I'll make it blue. So now I'm going to label my angles. Are you watching this? So this is angle 1. Down here is angle 3.
They're both 40.
3, 4, 5, 6, 7, 8. All right, let's look over here at 5, 6, 7, 8. Is 6 and 7 anywhere in the actual diagram? Nope, so I'm going to forget about those. Is 8 in the diagram? Nope, so I'm only going to focus on angle 5. So now let's go over to these other 4. 5 is an alternate interior with 3, but is 3 in the diagram?
No.
Nope. So what other angle is angle 5 congruent to? Angle 1, y, what type of angles are they? Well, you have all 4 listed on the front of your notes. They're corresponding, right? So x would be how many degrees? 70 degrees. Good. Oops. Now, how can we find y? Well, we got 2 ways we could do it. What should be true about these 3 angles? Not the same.
She just wrote it x equals 70, right?
180, right? Because all 3 added together make a straight line. So if x is 70, 70 plus 50 is 120.
Be 70 again.
120.
Be 40.
Subtract that from 180. 60. So y would be 60 degrees.
Don't make fun of me, Larson.
We almost had it.
I had it. Okay?
All right, so now take them a little bit harder and flip onto the back and justify what we are doing with some if-then statements. So we need to, 1, find the value of x, and then 2, state the theorem of why we can do that. So I have an angle of 70 degrees here, and then I have an angle of 3x minus 14 down here. Are those angles corresponding, alternate interior, alternate exterior, or consecutive interior?
Exterior, interior.
Corresponding, top left, top left. What's true about corresponding angles when lines are parallel?
They're equal.
They're equal. So we're going to set those two expressions equal to each other. So 70 equals 3x minus 14. Adding 14 to both sides gets us 84 is equal to 3x.
Wait, what?
I add 14. Do you want me to put the plus in there? I'll show it. Plus 14 to both sides. Divide by 3.
What is it, 56 minus? No.
So 3 goes into 8 twice. Remainder of 2, 4, 28. So x equals 28.
Wait, what is it? After 84 equals 3x.
So now we need to justify it by one of those 4 if-then statements that we wrote on the front of our notes. But we don't have parallel angles. We're going to have if parallel lines. Yeah, then corresponding angles. Good. Corresponding angles are congruent. Would work. Got that, Aaron? Yep. Yeah, if you want to be lazy about it, go for it.
If parallel lines, what?
Then corresponding angles congruent.
Parallel. Correspond.
Angles congruent.
Are congruent?
Yep. All right, so now look at the next one. What relationship do we have out of those 4? Same side or consecutive interior,
So
right?
Equal 180.
And consecutive interior angles are supplementary. So that means we're going to add them. So 75 plus 5x minus 10 equals 180. Combine your like terms. Some of you guys are still doing this. Watch so you don't do this. Why is this step right here incorrect? On the same side. No, 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 no. I sound like I'm talking to my 16-month-old. No, 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 no. Okay, so 75 and a negative 10 is 65 plus 5x equals 180. Subtract your 65, which I heard it is 115.
What is that?
So 5 goes into 11 twice. Remainder of 1. Yep, I'm doing long division. So 5 goes into 11 twice with a remainder of 1. Bring down the 5, so 15. 5 goes into 15. 23. 5 goes into 15 3 times. So x equals 23. What's my if-then statement?
If parallel.
Parallel lines. Then consecutive interior angles are sup. So they are what's up.
I don't like these sentences.
You are welcome to write them all out.
No, I do.
Oh.
It's just a confusing thing. That's what I found.
Then consecutive interior. Do you want me to write out more consecutive? Consecutive interior angles are supplementary. Okay, now make sure, and I'm going to tell you, there are many of you who probably will make this mistake. Don't let it be you. You'll write the correct statement because you'll have these memorized, 4 of them memorized. You'll write this statement and you're going to say that these are supposed to be supplementary, and then you go up here and you'll set these equal and solve for x. Does not match. Here you said they were supplementary. Make sure you make them supplementary. In the previous one, we said we had congruent angles. Make sure you set them congruent. Don't add them and then equal 180. So make sure that your work matches with your statement. Does that make sense? Because some of you will do it. Don't let it be you. Got it, Kian and Aaron? Good. All right, let's finish with our 2 proofs. Does anybody have any questions with what we've done so far? All right, so our first proof is to be actually proving the alternate exterior theorem. So we are given that A and B are parallel to each other. We need to prove that angle 1 is congruent to angle 4. Well, they are congruent because of the alternate exterior angles theorem, but we're going to prove why the alternate exterior angles theorem works. So set up your T-chart. Statements on the left. Reasons on the right. And then the given, yep. So we are given that line A is parallel to B. Okay, so we need to connect 1 with 4. Well, is there an angle in here that 1 is congruent to? 2. Why? What's perfect? So angle 1 is congruent to angle 2. Remember, your hypothesis of your if-then statement should always link up to the previous thing that we talked about. What did we talk about here? We talked about parallel lines. So if parallel lines, then, well, we know that they're congruent because corresponding angles are congruent. What other set of angles do we have congruent? Is there another angle that 2 is congruent to? 4. Good. Why is 2 and 4 congruent? Because they're vertical. So let's put that in if-then form. So if angles are vertical, then congruent. All right, we're almost there. One more line. If 1's congruent to 2, and 2's congruent to 4, nope, 3's just there to throw us off. So 1's going to be congruent to 4, right? Which is what we're trying to prove. We're trying to prove that angle 1 is congruent to angle 4. What property lets me do that? Well, it can't be substitution because of the congruency. It's going to be transitive, right? Substitution only works with equal signs. So this is transitive property. So there we did it. Fill it in the blank. On the quiz, you might be given something very similar to this, where I give you the left side and you just have to fill in the right side. So you want to make sure that you can do that type of thing. So you need to identify where you have corresponding angles. Maybe you have vertical angles in there, and then the transitive property. All right, last proof, which is also very similar to the one on the quiz. So you want to make sure you're good to go with this one. Let's go ahead and set up our T-chart. Statements on the left. Reasons on the right. Here we are given quite a bit. We are given that line segment ST is parallel to line segment WQ. And we're given that line segment ray TS. Oh boy, bisects. What does that mean again? Cuts it in half, right? So we're going to get 2 congruent parts out of that. Bisects angle WTR. Okay. We need to get angle STR to be congruent to angle TWQ. So let's first focus on our parallel lines. So here are my 2 parallel lines. Probably should use a thin line so I'm not covering up the letters. So here are my parallel lines. Here is my transversal. Oops. So, out of these angles, does this angle have anything to do with my diagram? No. Up here? No. Here? No. This one? Yes. So this angle would be congruent to what other angle? Well, the corresponding down here, but that's not in here. So let's go alternate interior. Do you guys see the alternate interior angles? So this angle here is going to be congruent to this angle here. So now I actually have to put that in my proof. So let's name it. So that first one, I'm going to call it angle TWQ. Is congruent to angle, well, not STR, STW. Give me an if-then statement.
If.
Well, start with if parallel. They're not exterior, because they're in between the two lines. Alternate interior. So alt int angles congruent. Okay. So now we got those. Now let's go to that bisecting part. So it's telling me that angle WTR is being bisected by this ray. So where alternate interior angles congruent. So where are my two congruent angles up here if ray TS is bisecting? Yeah, here and here, right? So now let's put that in a statement. So over on the left, line 3. Angle, I'm going to go STW just because that's what I used here. STW is congruent to angle STR. What would be an if-then statement for that? What do we talk about?
Parallel. Then.
If bisect, what's being bisected, an angle or a segment? Angle. So if angle bisector, that's what we're talking about up here. We had an angle bisector. Then what happens? We end up with congruent angles. Good. Then congruent angles. That would work. All right, we're almost there. Last line. So angle TWQ is congruent to angle STW. Angle STW is congruent to angle STR. I want to prove that STR is congruent to TWQ. So what property is that? Transitive. And because I don't feel like doing the symmetric property, I'm just going to write it the way that the proof is, so I don't have to flip it. So angle STR is congruent to angle TWQ, which is your transitive. Just rewrite the proof line. That transitive property is going to come into play a lot in section 3.2 and 3.3. Okay?